library, it's using data analysis, it's using data science, it's using data engineering, which is why we teach it. Um, the key part of the key data type of pandas is a data frame. Let me just see if there's another chat. Yeah, we will also, in terms of the matching, we will match based on interests as well. It's not so easy to have everything line up perfectly, but yes, like if you have a preference for a kind of domain, or whether like it's a subject matter or it's a technology, we'll do our best. You know what I mean? Like obviously, I'll try to make it as enjoyable as possible. Um, but by the way, we vet like a good amount of companies, so we're already like pre-selecting, trying to give you guys like the best companies we can. Okay, and more questions? What's the general timeline for the internships? It's no questions. And no problem. It's from end of February through May, through the end of May. All right, and then if you're available after, basically the way we tell companies is if it's mutually beneficial or like upon mutual agreement, like you can continue the internship. So for a lot of students and a lot of companies, it makes sense just to keep going. And I can just tell you right now, if the company's willing to keep going, right? Like the more months you can kind of say that you have this experience, the better. Uh, right? And then, right, you can kind of call it like almost, it just looks better on your resume. So if there's an opportunity, like, and things are going okay, do it. Just do it. Cool. Um, all right. Yeah, there won't be an interview. Maybe once in a while, student companies ask for like an interview with before they get paired, but it's not super common. So in most cases, there won't be an interview, and if it ends up not being a match, we'll just match you with another company. It won't be a big deal. All right. So pandas. So you can see, like, we use the pandas library. This is very typical. Import pandas as PD, right? This is just a shorthand, obviously. And then we, basically, whenever you kind of load in a data set, pandas is trying to create a data frame out of it. Okay, so this, if you look at this, the type of this, I messed up. This is a pandas data frame object. Okay, and then how do you think of a pandas data frame? Basically, it consists of like rows and columns. So let's take rows, columns, and an index. So if you do, let's take a look. We can just slice a couple rows. Take a look at this. So if we do dot year, or we'll do one way to select column is year. This returns for us actually a new data type, which is called a series. Okay, and a series is kind of like your column. I think the row also is a series, and then these are just like various series like stacked together. So the reason why this is a different data type, right? This series, and the reason why I bring it up is because a series does have some methods, right, that like a data frame does not. For example, I don't think this will work if I do like dot head. Oh, I'm lying. That does work. But there are certain methods that will work on a data frame, but will not work on a series. The pandas interface updates pretty often, so that's why sometimes they are just adding to it. You can see that this series has to be consistent with the data type, right? So this one is like integer. I think this is the number of bits that it's allocating for it. It's also a named data type, right? It's called, you can see the name is year. And each component, both a data frame and a series, has this thing called an index. So if you see the movie's data frame, right, you can see this thing on the left here. That's the index, okay? So you can do dot index, I believe. And this is returning to you a different kind of object. This is like the index data type, all right? So when you think of a data frame, you can think of it of the series that it consists of, right? It consists of this other data type of a series, and then it also consists of an index. And the index is a way to select. You can select rows specific rows by the index. Okay, normally the way I do that is this method called iloc. So you can do .iloc, like I did 0, and you can see that gives me back the first row. Let me just see. Right, here's the data frame, and then I did .iloc square bracket 0, and notice the data type that it gives me back. I believe, let's take a look. I believe this is a type series. Let's take a look. You see that? So it's like you have this series, this is kind of like the atomic unit, I guess, in a way, right? Whether it's a row or a column that a data frame consists of. Okay. So, yeah, the first thing we can work with is just kind of selecting columns. This is oftentimes what you want to do with a data frame. So there's different ways to select columns. One, you already saw. You can select it basically by putting the column name the same way you would with a dictionary, right? So you can just do like IMDb. This is the way I normally do it, just like that, okay? The other way that you can do it is you can do the dot notation. So you can do .imdb. The reason why I don't use this as much is, it's not a good practice, but let's say you have a column that has like 2 words, right? Which you shouldn't do, but let's say it just does. You can select that with the square brackets, but you cannot do that if we just do like .clean space test, right? That's not going to work. Okay, so this is why I do. I normally lean on the square brackets. Let's just see if there's other questions. Will the index be? So we have a question. Will the index be the same for all series in the data frame, or will be different in empty cell values that are not considered? So for every row, each row gets its own index value to select from, regardless of whether there is like present or no values here. Okay, so you can always kind of, so you can always select by doing like the iloc and then specify the index that you want to get back. So again, the first thing is selecting columns, right? I prefer using the square brackets. That's just my personal preference. That works fine. If you want, and what's the return value of this? It's a series, okay? Now, if you want to select multiple columns at once, the syntax feels a little confusing. So you still do the square brackets, and then I like you kind of can break it out like this. So there's a square brackets, and then here is another list, right? And this is a list of columns. So do year, comma, IMDb, right? And that returns to us, because it's multiple series, this returns to us a data frame, okay? Because I just don't like, I find this syntax kind of confusing maybe. So lots of times what I'll do is I'll assign this to be like columns, and then do that, okay? So it's like I put my selected columns here as a list, and then I just pass through that list. And to me, it's just a little more clear. Other things you can do, you can drop, this, by the way, this is returning to you a new data frame, so it's not modifying the original movies data frame. Okay, this is unchanged. And then another thing to note is another way to kind of select a subset of columns. Let's say here I'm saying what I want to include. If instead you want to specify what you want to exclude, you can use the drop. So let's just take a look again. These are the columns I have. Title. Let's say I want to drop this one, right? Or let's say we want to, let's drop both of these. What you can do is do drop, do columns, with an N, equals, and then we'll say the columns I want to drop. So it's test, and then clean test, okay? And this, again, this returns to us a new data frame, so it's not modifying the original, but now you see those columns are gone, right? The test and clean test columns are not there, okay? So what I'll do is I'll just like assign this, like select the DF or whatever you call it, assign this to a new data frame and then work with this. Okay, so that's mainly working with columns. The other thing to know about working with columns is oftentimes it's pretty nice just to get a sense of like what are the columns, what are all the columns. So you can see one way I'm doing this is just slicing the first 2 rows, and that shows me the names of the columns. But if you want to just see the names of the columns, you can call dot columns, okay? And this is, look, these are our 2 data types, right? The series and the index. So this is returning to us an index object. So this list right here is an index object, and it has a list of the columns, all right? Why is this useful? It's pretty useful because then you can just, select, copy and paste it, and then, choose which ones you want. Like we don't want these, let's say, and now I can just pass this through and say these are my selected columns, and then just pass it through here, right? And now I have the columns I want, okay? Yeah, right here, okay? So that's not so bad. So this is the way that we select certain columns, right? We can do it, as you saw, we can do it with the square brackets, right? And just pass through the string. And then the only tricky thing is selecting multiple columns, right? To do that, you use the square brackets, and then you pass through a list, okay? And that returns to us a data frame if we're selecting more than one column at once. Okay, so then the next thing after selecting columns is selecting rows. So I showed how to do that. So we have our entire data frame. We can, I guess there's different things to know. One, you can select, you can slice it just like, you're slicing a list. Gives us the first 2 rows, okay? You can also do like 2 to 5, just like a list, right? This gives us starting at 2, 3, 4 exclusive, right? I think this works just like a list does. And then there's 2 different, typically you can use this index locator. So let me show you that. So the iloc kind of works the way you'd expect. This is giving us the first row, right? And then the second row. And let's just make sure of that. So just slice the first 2, right? And this is giving us the second row, right? 2012, judge, whatever this is, Dread 3D. Another thing, though, that I guess is important to know is we have the selected DF. It is possible to, let's say you want to set the index as like the title, okay? So we're going to do dot index equals, I can't just do like title, right? That doesn't make sense. I need to set it as this series, okay? So I'm going to re-index this. I'm going to do selected index of selected DF square bracket title, right? So this right here is giving me that series. And now I'm going to reset the index and set it equal to this. And we'll take a look at what happens. So right now we are like updating this data frame. And you see this? So now we've changed the title, okay? The index is now this title. We still have title here, but now the index is this. So now we can still access, let's say we're like, I want to get the first row. You can still do that by using iloc square bracket 0, all right? And that gives you the first row. However, now there's another way that you can access things, and that's using loc. So loc is for like a named index. For instance, let's say now you're like, I want to get Dread, whatever this is, 3D. I think there's no space, right? This is retrieving it, okay, by the named index. Why is this useful? One thing to note is, you can pass through a list here. So let's say you identified the movies that you want as like 42 and whatever this is, Beyond the Valley of Dolls. You can, that's a little annoying. Let's just do these 2. We'll do Dread 3D. And 2 guns, whatever that is. Okay. So you can pass through, like these are my, the rows we want. And now you can do .loc and pass through a list here of kind of what the names of the index you want. And it will just pull them right out. In other words, it's not filtering through them. It's like it's hashed them and it's just immediately finding them. So it's just a faster mechanism than kind of looping through, which you can do. You can loop through these and find specific rows as well. All right, so you can pass through a list and select based on the index. You can do that also with iLoc. So with iLoc, if you want to pass through like a list of values, like 0, 2, and 4, then you can pass through that, and this is giving you the first, third, and fifth, I believe, rows. Let's just make sure. So there's the first one, 21 amp, the third one, right, because we did index 2, right, and then the fifth one, 1, 2, 3, 4, 5, 42, okay? Let me see, more questions. Would we want to remove the duplicate column? Yeah, you can. I'm not sure. Like, it depends on how you use it. In some cases, yes, and honestly, in some cases, no. For instance, like, say this is predictive. Sometimes you might want to feed all the columns into a machine learning model. So that if somehow the title is predictive of, like, the performance of the movie, maybe you want to, I don't know, you want to just feed everything in there. Next thing. So I said there is a way to filter, right? So we saw kind of one way, I guess, to filter. Like we can set the index to the title, and then we can just pass through, right? .loc, right? Like a list of titles. So we'll do this Dredd 3D, right? And that gives us back one of them. By the way, we can't, if we don't use loc, I don't think this is going to work. Like, I can't just do this. Like, that doesn't work, right? It thinks that you're looking for a column here. So you have to, use the .loc to specify I'm looking for this on the named index. But there is another way to actually filter through our rows. So what would that be? Well, here, like, it kind of makes, it's okay, I think, for us to set the index as the title, because these are unique, right? There's only one per each, one row, one title per movie. But we wouldn't want to set something like the year, or let's say the budget. Yeah, the year is a good example. Or the year to the index, because there's going to be repeats all over the place here. So let's say we want to find just those movies in the year 2013 that were made in 2013. How do we do that? All right, let's slice this just to make it a little smaller. What we can do is, here's what we'll do. So we're going to first select the year column, okay? So this is the year column, all right? This is a series. So for each movie, did I do this right? For each movie, why does this say title? Is this messed up? Oh, there it is. Sorry about this. This is the index, and then this is the year. My bad. So this is the new index, right, of this series, and then this is the year. Okay. So what can we do? So by doing this, we're first getting the values, right? And by the way, I think you can even call .values here, and it gives me back, like this is now converted basically into an array. So we can now filter and kind of ask this question, does this value, does this year equal a specific value? With pandas, and this, you're going to have to remember this, with pandas you do not need to loop. Please do not forget looping in Python. But with pandas, you do not need to loop. You can just kind of ask the question. For each one of these, for this entire list, does this equal 2013? All right? And it's going to produce true or false. Okay, so for the first movie, it was made in 2013, but this movie apparently was not. So what we got back is this new series of true and false values. Okay? Now what you do is you pass this whole series into the data frame. So let's even call this. This is my Boolean series. Okay? Right here. And now we can pass this set of true or false values into the data frame. So I'm going to do selected df, square bracket, right, and pass through this series into the data frame. It will only give me back those rows for which the Boolean series returned true. So you see that? Let's do this one more time. So let's say we want to filter, based on some sort of characteristic. Like, let's do another one. Let's say we want to see, are there any where the budget is $0? Or let's do ones that are, let's do ones that are 2012. All right. So what do? We do selected DF. This is my data frame. Select the series. So that'll be the year. And then we'll say, is the year equal to 2012? This will return to me a series just of true or false values. Okay? You pass this series into your entire data frame. See that? Then you press shift return, and this returns only those movies in 2012. And you can do any kind of, so you can say where the year is greater than, let's do less than like 1975. So you can do any kind of query, kind of Boolean expression that you want here. So this will still return my true or false values, and then I pass that series into the data frame, right, into the square brackets to say I just want to select those where this Boolean series is true. Okay? That's how that works. Questions about this stuff? Now let me see. Obviously there is. Can we combine? Yes, you can combine like multiple expressions. So you can say, I think the and or works fine. Either if that's not true, then you might have to do the ampersand. Let's see. And I'm probably going to mess this up. And title, it would be like this. Selected DF, DF of title equals Black Christmas. I have no idea if let's see. I messed it up. I'll have to, look what it says. The truth value of the series is ambiguous. I'm not sure. I might have to do it like this. No, I'll figure this out. I'm going to have to Google this. But there is a way. You can do multiple expressions, without a doubt. I'm just messing it up. Cool. All right. I think that's pretty good to get started with. The reading should do a fine job too. Okay, cool. That seems to be working. All right, so let's download some data. We'll work with a 538 data set right here. Okay, so this is my movies DF. And then, there's just different kind of like exploring data type things we can do. So, you can look at the first couple rows. You can do it the way I've been doing it, which is like the /2, right? :2, which will slice the first couple rows. You can also do the other way. So it'll be -2 to the end, right? The last two rows to the end this way. So that would give us like the last couple rows. You see that? 1792, 1793. The other way that people like to do is you can do head, which I think by default now gives you the first 10 rows. No, it's 5. So you can do the first 5 rows there. But then this also takes an argument. So if you want to do like head, but only 2 rows, right, that will work. You can do the same thing like tail if you want, right? Which this will give us the last 2 rows. And if you don't put an argument here, it'll give you the last 5 rows. Okay, so sometimes you use this just to explore like what's the range of data, quickly in the data set. It's not perfect because the data isn't necessarily sorted, but lots of times people will do something like that. If you want to get an overview, so of course, like we saw this movie df.columns just to do that. What you can also do is movies df. I think it's dtypes. So this is returning to you a series, all right? And then from there, so it's telling you not only the name of the column, but then also the corresponding data type. And then from there, what you can do is .select dtypes. So this works on a data frame. And then you can specify like which one of these you want. I think it's, can I do this? Let's see. So I'm first going to just do object. Will that work? So now this is just giving me the data types that are of type object. So you can see that if you do .dtypes again, just on this subset, right? They're all of type object. I think this also takes a list. So if we want to do like our numeric, right, int64 and float64, let's just pass that through as a list. So int 64 and then float 64. And I broke it. Oh, 64. Okay, so now same thing, right? You can do .dtypes, right? And that's, that's only returning our numeric data types. Okay, so in the same thing, if you want to pass this through, right, numerics, you can do that. Okay, so we saw the describe. Oh, we didn't see describe yet. Let's talk about that now. The other thing that people would do oftentimes just to get like an overview. So there's like head, tail. You also see describe. Okay, and this basically for every numeric column will return to you like the count, meaning the number of like present values. So this is why they're all basically the same. The average, so the average year is 2002, standard deviation, min, max, right? And then the interquartile ranges, max and min. It's only doing that for the numeric columns. It's automatically leaving out any of the objects. And by the way, in pandas, object, sorry about that, let's just call it dtypes. In pandas, objects is like our is string, right, for Python, like they're equivalent. Okay, so what do we learn so far, right? We learned about kind of like this dtypes thing, which shows us the column and the corresponding type. We saw that then we can like select certain data types, and that like certain methods really are just designed to work with certain data types, like the describe method. Another thing that's useful that probably came up in the lab, but maybe you didn't know it, is if you select a column, like let's do this. Let's go back to year. One thing that's useful is figuring out like a count for each year. So that's value counts. Okay? So this is the raw number, and then this takes an argument, I forget what it is, where it would convert it to a percentage. Oh man. Let's see if I can. I just forget. Anyway.
Normalize equals true.
Thank you. I think that is correct. Okay, normalize equals true. So this now divides basically the amount by the count, by the size of the data set. So you can see it's ordering it for me here from greatest to least. And because it's a series, right, I can slice it to like the first 10, the top 10 if you want, something like that. So I want to see the top 10 years by percentage, right? It's, value count. I start with a series of data. The value counts basically gives you like a histogram, right? It buckets it and then gives you an amount of each one, right? And then the normalize equals true. So if I don't do the percentage, it's just a raw count. If I do the normalize equals true, it gives me the percentage. And then this is returning a series, right? So you can do anything you normally can with the series, right? You can do .iloc and pass through, or really, here's probably you can do .loc and pass through like 2010 and 2011 if you want, right? And that's returning those two. And then, of course, we saw you can slice it, whatever. Okay. So this is very useful, this value counts thing. The other way you can do this, right, we're doing like a histogram, right, meaning we are grouping by the year and then counting it up. So let's see the other way that I guess you can do this. This is a little tricky. So let's comment this out. So let's say we wanted to do group by, we could do movies df.year, and now if I do group by here, right, I don't even know if this will work. Yeah, so okay, group by, I have to specify what I'm grouping by. There's only one thing because I'm selecting just the series year. And that's not working. You see it has this key error of year. That's because there is no column, like in the series, there really is no column of year, you know? So one thing I could do is stick with the data frame, right? And then probably could do, so I just wrapped another set, right, of brackets here. That way it's passing through a list of columns, and that gives me back a data frame. But that's probably not good either. Like I'd have to group by year here, but it's already just kind of, I don't know. Maybe this will work. I'm not sure. Yeah, it doesn't. It look exactly what we want. It's not helpful, is it? Okay, so here's a better idea. So we start with our movies DF. We can instead select multiple columns. So I'm going to select. Actually, we'll just do all of them, and we'll do movies DF dot group by the year. Okay, this kind of leaves me that intermediate step, and then I'll do dot count. Notice what's happening here is this is correct, right? But it's giving you the same result across each column. That's because what is counting up is counting up the non-null value, the present values, right? If you get like an NA value here, it won't count that. Same way in SQL, right? If we do count, it counts the present values, but null values it will exclude. So all these columns basically have null values. They don't have to, like this one doesn't, apparently. In gross is missing one for 1972. So what you can do is just like select a column that you know is going to be present in the data set. For instance, for movies DF, right, like we kind of know that this IMDb is probably present. So you can do .group by year, count, and then just select IMDb, I'm guessing. So that works. And then I think there's like sort values. Can you sort the values? Yeah, so sort values. I forget this. You can sort this descending. I just have to look it up. I'm not sure. Oh, it might be reverse equals true. I'm not sure. It's something like that. But anyway, so you can see how we did this, right? Is I'm sticking with the data frame. I'm then grouping by just like SQL, what I want to group by. The count is going to work across all the columns in the data frame, right? Counting the present values, and then I really just need one of them. So I can do, I can just choose one that I know is going to be present. So that might be IMDb, right? And that works out pretty well. Maybe someone told me what it is. Ascending equals false. Thanks, David. All right, so let's do that. So now I'll do dot sort values and parentheses, and now in here do ascending equals false. See, now it's showing me some documentation, which is nice. Cool. So here's my ascending equals false, right? And we can do the same exact thing, right? Like divide by 10. It's just slice the first 10. So we saw two different ways to do the same thing. One is this value counts. Notice that it's automatically kind of doing this for me. 2010, 129. Here we're getting the same results, right? But I'm using a group by, specifying what I'm grouping by, the year, counting them up, and then just selecting something I know is going to be present. Other things you can do that perhaps I should talk about is, like, how do I know this is, it might be useful to know, like, the size of the data in general. Like, for instance, if we had this normalize equals true thing. Let's do this here. Okay. So we got 7%, right, of the movies in the data set were in the year 2010. How can we do that with this method? Well, what you can do is get the size of how many rows there are. There are a couple different ways you can do this. One is you can just ask like the length of the movie's data frame. It says 1794. The other thing you can do is called .shape, and this will give you the rows and columns Notice there's no parentheses here. So there's 1794 rows and 15 columns. Okay? And then the next thing you can do, and this works with anything in pandas, you can divide by a number of rows. So you can divide by 1794, and now this is converted, right? The total amount, or the amount divided by the total, right, is giving me the percentage. So that's why these are lining up. So this is called broadcasting. Let's just see it again. So we started with the series, and basically we're saying I want to divide each of these elements by a specific amount. So divide by 10 this time, right? And now it divided by 10. So this is taken from like a matrix algebra thing. It's really comes from NumPy, which Pandas is built on. I think it's just been a while since I used NumPy. But let's say we have a bunch of numbers here. So this will be my array. The way this is in matrix algebra, this is considered a vector, right? Like a list is a vector. And then a single number is a scalar. So if you do 3 times a vector, if you do a scalar times by a number, it will apply this to each value. All right? So I'll do 3 times array, right? And I don't have to loop through it, right? It's applying it, it's kind of distributing it to each value. Same thing, we can do array divided by, 10, and now each one will be, right, 1/10. This works to a data frame as well, right, because that would just be like a matrix. So if you have this, let's take this movies DF. Let's just select a couple columns that make sense. So budget and domestic gross, budget and dom gross, right? So this will be my selected DF. And now, cool. So this is a data frame, same type of thing. We can divide this by like 100, and this will apply to everything here, right? You can see the decimals now. Okay. So yeah, it's just something, I guess, to get used to. It's also the reason why we can kind of check equality. Like we can say, does it equal this value? For everything, like across the entire data frame, and we only get one true value, right? Because you're kind of asking this question across the entire matrix of data. So what do we learn? With exploring, right? We saw you can use the value counts. The value counts produces a histogram for you, right? So it's giving us 7%, right? Or in this year, 2011, right, is there's 6.9%. And then we're getting to the same result by doing a group by and then can do count, right? And this is doing a count across all of the columns in the data frame. So that's why you kind of are seeing these same results across. And this works for any of the, like you do mean, right? And this will give us the average, so this is the average, per year. What is the average gross, how much money did it bring in per year? What was the budget, right? Things like that. I wonder if you can also select this way. I'm not sure. No, that didn't work. That was stupid. All right. So instead, if you just want to select one of them, you can just then select from this data frame. Okay, so that's what we did. We did count, and then we selected IMDb. Cool. One other thing to show is, so this is producing for us, right? Especially the value counts is what I normally use, is producing for us what I call a histogram, meaning it's grouping by basically this amount. It's grouping by, if you started here, it's grouping by the index, by this thing, putting them into buckets, and then counting up how many it saw each of these values, right? If you call if you call movies df, let's take out the normalize equals true. If you call movies df year dot hist, so just remember, this is a series of data, right? I'm going to call dot hist here. It will plot a histogram, meaning it will group these by their value and then plot the number of times each occurs. So that's what's happening here. Okay? So if in the lab, when it asks you to do a hist, it's actually not that hard. What's hard about it is it does a lot of work for you, right? It does the value counts and then plots that. So if you plot this, you don't want to call .hist after this, right? Instead, you do something like you'd probably somehow produce a bar chart. Maybe it's bar. I don't know. I'd have to look it up. But there is a way. I just would have to think about this. But you could probably take this value, take the index, and take the values. Where did it go? Take the index. Here's the index. And then you could separately take the values, right? And then plot them side by side, right? We could do that. Maybe someone knows. Is his part of pandas in this context or available? Yeah, okay. So Miles is asking, is his part of Panda? Hist is coming from matplotlib, but Pandas just throws everything into, as many things as it can into its library. And so Pandas builds in matplotlib. I don't think you need to know,